Hi and welcome to lesson of multivariable calculus. So in today's class, we are going to start discussion on the functions of several variables. So before embarking into the topic, let's just start with some basic single variable calculus, in which we know that we write a single variable function in terms of y equals to f of x, where y is the dependent variable and x is the independent variable. So we can see here that we have only one independent variable, and it's a relation from some set x to some set y, such that each element of this set x should have a unique representation in this set y, right? So each element is mapped with an element in y, right? And every for every element in the set x, the image in y should be unique, right? So it cannot be like that one is mapped to a and then one is mapped to b as well, right? So it cannot happen. So the image should be unique. So this is the definition of function in the single variable calculus. And in case of the multivariable calculus, now we have more than one independent variable, so we can write uh, z equals to f of x comma y in two variables case, or we can write w equals to function of x, y, z in three variable case. So here we have three independent variables, here we have two independent variables, and the function here maps, let's say in this case, maps an ordered pair x comma y, let's say 1 comma 1, negative 1 comma 2, and so on. So elements like this to a set whose elements maybe like a b c d or 1 2 3 4, like that, right? So the domain set in multivariable function is an ordered pair, right? An ordered pair, unlike in the single variable function. In the single variable function, we have just a set that may be of real numbers, of integers, of rational numbers, and so on. But here we will have an ordered pair in case of multivariable functions, right? So for example, let's take an example of a multivariable function. Let's say we are interested in volume of cylinder. So we can see here that volume equals to pi r square h, where r is the radius and h is the height of cylinder. So now we have two independent variables, because radius might vary, height might vary. So volume depends on radius and height. Radius and height. Therefore, we can write it as the volume is function of radius and height, right? Where pi is constant, so it's fixed. So r and h may vary. So we can write that volume of a cylinder is function of its radius and height. So here we have two independent variables. Therefore, it's a function of multivariables, right? So the definition of two variable function, we can use this definition. That is, it is a rule that assigns to each ordered pair of real number x comma y in set D a unique real number denoted by f of x, y, right? So we have the domain as an ordered pair x comma y, and the range here is z, right? So it's a single element. So the function f of x comma y, let's say the domain might be like this: negative 1 comma 0, 2 comma minus 3, 1 comma 5, and so on. And the range set, it will be like let's say 0, negative 1, 2, 5, and so on, right? So we have single element in the range uh, set, right? So it's rule that assigns the ordered pair of real number x, y in set D unique real number denoted by f of x, y. The set D is the domain of f, and its range is the set of values of f that takes on, right? And we can write its domain as f of x comma y such that x comma y belongs to the domain set, right? So in this manner, we can represent a function of two variables, right? Now, let's take an example to see how we can find the domain and the range of multivariable function. So we have example here. Let's say in this example, for each of the following functions, evaluate f of 3 comma 2. So we need to find this value of function at this point, this ordered pair 3 comma 2, and we have a function f of x comma y equals a square root x plus y plus 1 over x minus y, right? Now if I want to find the value of 3 comma 2, I can write it as 3 plus 2 plus 1, where 3 is for x and 2 is for y, divided by 3 minus 1. So I will get square root 6 over 2, right? And if I am looking for the domain of this function, that is f is square root x plus y plus 1 over x minus y. So I need to consider two things here, that one is that this is a square root, so we should have a positive value inside the square root. So we need to restrict this square root function, that it should be greater than or equals to 0, and then the denominator cannot be equals to 0 in order to get the in order to make the function defined at that point. So we can say that this x minus 1 should not be equals to 0. So now this is the domain of the function. We can write it as x comma y such that x plus y plus 1 is greater than or equals to 0, and x should not be equals to 1. So this implies x should not be equals to 1, because if this is equals to 0, then what should happen is the denominator becomes 0 and the function will be undefined, right? So this is the way we find the domain. Now say this function here, that is f equals x ln y squared minus x. Now see here that this is the natural log function. This function is inside the natural log. So we know that natural log is only defined on the values greater than 0. So we can say that this y square minus x should be greater than 0. So it cannot be 0 because ln 0 is undefined, and also it cannot be a negative value because ln is not defined on negative values. So this implies that y squared should be greater than x. It's not 0, it's x, right? So now the domain of this function will be xy such that y squared is greater than x. So this is the domain of this function, right? And we can find the value 3 comma 2 by just plugging in the values 3 for x and 2 for y, right? So this will be the value of this function at 3 comma 2. So we can just find the domain of a multivariable function in the similar manner, right? Now just look at this example. That is it's a graph, or it's a table that shows the temperature and wind, right? So this is the temperature and this is for the wind speed. These all values are for the wind speed and these all values for the temperature, right, on the vertical values. So now what the problem says is that in regions with severe winter weather, the wind chill index is often used to describe the apparent severity of the cold. This index W is subjective temperature that depends on the actual temperature T and the wind speed V. So we have a wind chill index that is function of temperature and the wind speed, right? So we can see here that we have two independent variables. One is temperature and the other is the wind speed, right? So now what this represents is that this table represents that when the wind speed is 5 and the temperature is 5, the wind chill index, it will be 4, right? And similarly, when the temperature is, wind speed is 10 and the temperature is 5, we will get the wind chill index as 3 and so on. So all these values represent, like for instance, if I am interested in finding W of 40 comma minus 25, so I have to look at the table where the temperature is 40. So the temperature is 40 degrees. Let's say, okay, we don't have 40 degrees, so let's say negative 40 degrees, and here let's say that it's 60. So negative 40 temperature is here and 60 wind speed is here. So in this column and in this row, so the point of intersection is negative 64. So the wind chill index at this point, it will be negative 64. So this shows the intensity. Basically, this wind chill index shows the intensity of the weather, right? So similarly, we may have more examples like this. Let's say we have Cobb Douglas function, just right here, that P of L comma K. So it's a function that depends on L and K, and the function is defined like this. B, where B is a coefficient. Okay, so P is the total production. This is the total production. And L is the uh, amount of labor. Okay, and K is the amount of capital invested, right? So it's the capital invested. Okay, so and B is some constant, right? So this production cost depends on the labor cost and the capital that is invested, right? Uh, and now if it says that this coefficient alpha, right? Just take at this example. If we have alpha equals to 0.75 and b equals to 1.01, then the function would look like this, right? Now from here we can just find any value, like if we are interested in finding p of 147 comma 208, which means that the labor is 147 and the capital invested is 208. So we'll get the value, that is the production, as 161.9, right? And similarly we can find p of 194 comma 407 as well. So these are some practical examples of multivariable functions, right? Now let's take one more example. Find the domain and range of this function, right? So we are given a function that is g of x comma y, that is equals to 9 minus x squared minus y squared. So now first thing to consider here is that we have a square root function, so we know that it cannot be negative. So we should write it as this should be greater than or equals to 0. So it means that x squared plus y squared should be less than or equals to 9. So this is the domain of this function, right? And now we can just write it as d is x comma y such that this should be less than or equals to 9, right? Okay, now for the range, now what can be the range? So when we give this value, so values uh, values from this limit, as we have limited the domain by saying that this x squared plus y squared should be less than equals to 0. So now what can be the range of this function, right? So let's talk about its range here. Now see here, if I give here the values that are less than or equals to 9, so the minimum value that I can give here is I can give the value as let's say, since we are subtracting x squared minus y squared, which means that we are subtracting this value from 9. So the maximum value that we can have of this function is 9 minus 0, because if this is 0, then we are going to get the maximum because this value is subtracted from 9. And since the function is inside the square root, so we will get 3. So the maximum value here is 3, right? So the maximum of this range will be 3, and the minimum value that can be if this thing is equals to exactly 9, right? So we are going to get the minimum value, that is 0. So the range of this function will be from 0 to 3, right? So in this way we can find the domain and range. And let's look at the examples uh, here, which we only find the domain. Let's try to find the range. Let's say this function we have f of x comma y equals x ln y square minus x. Now, since we already established that the domain of this function is, this should be greater than 0, right? Now, what about the range? So we know that since ln is negative, if we input any value between 0 to 1, we will get negative numbers, right? And we can get the numbers up till negative infinity, right? And if we make it larger and larger, that is y square minus x, this value is larger and larger, that it tends to infinity, then this whole function, this whole value is going towards infinity. So the range of this function will be negative infinity to positive infinity, right? So this way we can work out for the domain and the range of the functions. So hope you guys understand this lesson. So in the next lesson, then we are going to start uh, the topic of three-dimensional spaces and how to draw the vectors in three-dimensional spaces. Thanks for watching the lesson.